Hello. On behalf of the Soybean Innovation Lab and the American Oil Chemist Society, thank you for joining us today for today's Soybean 360 Agro Processing in Sub-Saharan Africa Symposium. Our topic today is innovations in protein extrusion. We will cover several aspects of this versatile and cost-effective technology. The technology is so versatile that today we can only scratch the surface. We're excited to bring you these top-level speakers to share their broad experience in the field. First, Dr. Wilmot Wijeratne will lead off with a presentation about an early step in converting soybeans into food and feed, entitled Soybean Processing by Extrusion-Aided Screw Pressing. This provides an attractive and practical alternative to solvent extraction. This allows soybean processing on a smaller scale, and it's very scalable. So it's very much adaptable to the realities of smaller business operations. Then Dr. L.J. Grobler will bring the focus to processing of safe, affordable, nutritious foods from locally produced agricultural products using extrusion. Of course, given the logistics problems that happen in countries and with bad weather and with bad roads, this is a very practical kind of solution to using locally produced agricultural products. And of course, his company is the only producer of twin screw extruders on the continent of Africa. So he's very much familiar with the realities. Finally, Professor Marcela Gaytán-Martinez will conclude by addressing another food topic that many of us enjoy: snacks. Her talk is entitled Development of Snacks Enriched with Legumes and Cereals Obtained by Extrusion. She'll address both the essential health aspects of snacks and the all-important consumer acceptance aspect. So today, when you have questions, please enter your questions for our speakers into the chat feature so that I can ask them after each talk. In addition, we will have a panel discussion at the end. So if you have a question for the entire panel, you can enter that into the chat feature as well, but it would be very helpful if you would address your question to a particular speaker if there's one of those that you would like to have answer the question first. Thank you, and I hope you enjoy today's symposium.
I appreciate this opportunity to make this presentation on soybean processing by extrusion-aided screw pressing. By way of introduction, let me say that the conventional method of soybean processing into oil and protein meal is by the process of solvent extraction, a process in which the oil is extracted using an organic solvent such as hexane. Solvent extraction is a large-scale capital-intensive process that does not lend itself to a small agribusiness model. So for a long time, there was a need for an alternative method for small-scale processing of soybean, particularly for purposes of using the protein in human food applications. In the development of the extrusion-aided screw pressing process, there were three technical objectives that were set out. One is to prevent off flavor. Many off flavors have been associated and is associated with soy protein products derived from solvent extraction. Many off flavors present a challenge to using the protein in human foods. Secondly, there is a need to optimize the nutritional value of soy protein in any process. Native soy protein is not highly digestible for two reasons. One is that the soy protein is in a globular conformation where the molecules are folded, and the molecules have to be unfolded by the use of energy for the digestive enzymes to react. Second of all, it is well known that soybean contains trypsin inhibitors of the digestive enzyme, and these also have to be deactivated. Third objective was to enable mechanical extraction of oil without the use of an organic solvent. So let us review quickly the process outline. Starts with dry, mature soybean. The soybeans are cleaned to get rid of the light and heavy foreign material that comes from the field. And the cleaned beans go through a process of dehulling. Dehulling is the removal of the hull or the seed coat. Once dehulled, the dehulled soybean goes into the heart of the process, which is a high temperature, short time extrusion process. We'll talk about that process a little bit later. The extruded material, now known as extrudate, is then fed into a horizontal screw press, where much of the oil is pressed out, and the protein is captured, cooled, and milled into what is called low-fat soy flour. By matching the throughput of the extruder with the throughput of the screw press, we are able to operate the process continuously. Let us quickly review how this process met the three objectives set out. First is off flavor development. Off flavor is not inherent in the native soybean. If this is a native soybean cell, the enzymes that are responsible for generating the off flavors, known as lipoxygenase, by reaction with the triglyceride, this unsaturated fat in the bean, they are in the mature bean, but they are at different sites. So there is no off flavor. However, off flavor is generated in process. When the tissue is broken up, the substrate and the enzymes come together, and many off flavor compounds are rapidly produced. Most of them can be removed post-process, some of them cannot be. In the process of extrusion-aided screw pressing, we bring in the extrusion process right at this stage and deactivate the enzyme before it has a chance to react with the substrate. So we prevent the formation of off flavor. The second objective was to optimize the nutritional value of soy protein. Soy protein needs to be, like I said before, changed in the conformation from globular to a more linear by opening up the protein molecules by the application of heat energy. Second of all, the trypsin inhibitors have to be deactivated by heat. we are looking at a cutaway of a single screw dry extruder that is commonly used in the extrusion-aided screw pressing process. It consists of a central helical shaft rotating rapidly within a tight-fitting barrel. And at the end of the barrel is a die through which all the material that was put in have to come out. The dehulled soybean is brought into the extruder at this inlet port, and as the extruder screw works, it brings forward this material, subjecting it to friction, shear, and compression with the generation of heat. So the beans that went into the extruder at room temperature rapidly rises by the time it comes to the exit at the die. So the amount of heat that is generated within this period, which is very short, approximately 30 seconds, is adequate to optimize the nutritional quality of the protein. The third objective was to facilitate the extraction of oil by mechanical means. In native state, oil occurs in the soybean tissue within a discrete cell structure. The oil has to be released from this location before it can be pressed out by mechanical means. By the time the extrusion process is done and the material exits the extruder, the tissue is broken up, the oil is released from its original state into a matrix in which the oil is free and is warm. In this condition, the material can then be fed into a mechanical screw press and the oil is pressed out. The process can be controlled with certain independent variables, such as the extruder screw configuration, the die configuration, and the feed rate to achieve different desired outcomes. For example, temperature profile can be controlled between 115 to 145 degrees Celsius. The residual oil in meal varies between 6% and 10%. 6% is in fully cooked material and 10% is in the low temperature profile processed material. Protein dispersibility index, which is an extremely important criterion in process control, is varying from 15% to 60%. 15% is characteristic of what I call fully cooked material, and 60% is the number that you can achieve with low temperature processing. Power consumption is a highly variable factor based on the model and make of the extruder. So in a short period of time, we started with whole mature soybeans and then went to expeller pressed soybean oil and low-fat soy flour. A word about the typical chemistry of the processed low-fat soy flour. The protein content varies from about 50% to 65%. If we start with common, what is called commodity soybean at about 38% protein, we end up with a low-fat flour having about 50% protein. Whereas if we start with specially bred high-protein soybeans, the protein content in the flour can be as high as 65%. The fat content is normally at about 6%. In the fully cooked soybean, cooked at optimum temperature, but for high PDI soy flour, the oil content can be as high as 10%. So the range is between 6 and 10% based on the processing conditions and the extraction efficiency. Crude fiber content in the low-fat soy flour is between 2 to 3% if we start with dehulled soybeans, which is what we recommend for use of the protein in food product development. Total dietary fiber is about 16%, and the protein dispersibility, as I said before, is 15 to 65%. I threw in this number for total isoflavones. Isoflavones are health beneficial ingredients that are in the soybean. And the reason for putting this number at 2000 micrograms per gram is this is about the same concentration there is in the soybean. In other words, the process did not destroy or damage the isoflavones. Product functionality. Functionality is extremely important. In addition to the protein content, protein functionality determines to what extent we can use the low-fat soy ingredient in food product development. There are many different criteria that are important in terms of functionality. Emulsion capacity is one of those important criteria. Emulsion capacity is measured in terms of grams of oil emulsified by a gram of protein. Each bar in this chart represents a commercially available soy protein ingredient. Those bars in red represent ingredients made through the extrusion-aided screw pressing process, and the rest of them are derived from solvent-extracted protein material. The point I am making is that the emulsion capacity of the products made by the extrusion-aided screw pressing method is very comparable with those made traditionally by the solvent extraction method. There's at least 3 grades of low-fat soy flour that can be made in this extrusion press process by varying the operational conditions. First is what we call low-fat standard PDI soy flour. Standard PDI soy flour is fully cooked and the material is ready to use in food products. Low-fat high PDI soy flour. High PDI is obtained by processing at the lower temperature regime, and this material is to be reprocessed into applications such as soy milk and functional beverages. Low-fat micro-milled soy flour is finely milled low-fat soy flour that is used for further processing into soy protein concentrates or into instant beverages and frozen desserts. Few words about applications. In my opinion, the biggest possible application, the widest possible application is in what is called supplementary foods. Supplementary foods are products where the cereal staples are fortified with low-fat soy flour to bring about both an increase in the content of the protein and improvement in the quality of the protein. Low-fat soy flour, as we discussed, has about 50% protein, as opposed to cereals that have between 8 and 10% protein. So the combination increases the overall protein content in the supplementary foods. In addition, the protein in the soybean and the protein in the cereals, they complement in their amino acid compositions, so that the amino acid composition of the combination is better than either one of them alone. So supplementary foods bring about both an increase in the quality and quantity of the protein. Then we talked about high PDI soy flour, which is processed at a lower temperature profile. They are to be reprocessed. And this is an example of Silk soy milk, which is a brand of light soy milk made in the United States. And the base material for this product is low-fat soy flour produced by the extrusion-aided screw pressing process. Low-fat soy flour can be used in raised breads, such as bread and rolls. And we can use the low-fat soy flour up to 12% in standard methods of preparation without compromising the loaf volume and the crumb structure, which are important characteristics. However, when you get to cakes and cookies, you can use up to as much as 30% of the low-fat soy flour successfully in these different products. At this stage, I like to switch gears to talk about further value adding to the low-fat soy flour. And this is by turning the low-fat soy flour into textured soy protein. This is achieved by reprocessing the low-fat soy flour by a secondary extrusion process, which consists of conditioning the flour with moisture, conditioning with steam to activate the protein, and retexturizing in a texturizing extruder, which is a different one compared to the one used in the original primary process. The texturizing extruder transforms the soy flour into textured soy pieces, which can then be size reduced based on needs, dehydrated. They have to be dehydrated because we added moisture at that stage, and this size separated. And these materials can be produced in different particle size, large and small, and also either plain without color or with added colors based on the desired application. Typical attributes of the textured soy flour made from low-fat soy flour is it's flavor neutral. We go back to the original primary process where we deactivated the lipoxygenase enzymes before the process. So subsequent products do not carry any off flavor. It's flavor neutral. Second is it's got an excellent mouthfeel. You remember the chemistry of the low-fat soy flour, we had anywhere between 6 to 10% of oil remaining in the product. And that product is carried through all the way into the textured product. And the oil, as you know, oil gives a good mouthfeel. Rapid rehydration. Rehydration is important because the processor receives the dry textured soy protein. They have to be wetted or hydrated in order to incorporate this into any product. And this material, the structure is open and porous, and it will rehydrate in about 10 minutes. It's a short time. Typically, it takes about 30 minutes to rehydrate textured soy made from solvent-extracted soy protein. Water absorption is all important because it has a bearing on the yield of the final product. The material has the capacity to absorb about 3 times its dry weight in water, and that happens in about 10 minutes. By tests, shelf life tests, it has been found that the shelf life of this material is better than 1 year. Advantages of the textured soy protein: it is commonly used to extend meat ingredients which are in limited supply. When you do the extension, we enhance the protein content because the textured soy has 50% protein to enhance the meat ingredients, which are high fat in general. Third is reduce the formulation cost. In most circumstances that I have experienced, textured soy is always less expensive than the meat ingredient. So the overall formulation in the extended product is cheaper. Reduce fat content. Fatty meat cuts can be extended with textured soy, and the overall fat content will be reduced because the textured soy brings only about 6% fat into, for example, a 72% lean beef, where the fat content can be over 20%. Textured soy also prevents cooking loss. If you think about a meat ingredient that is extended and made into a patty or a hamburger, if you will, when you cook or grill that material, if it is 100% meat base, then there is loss of water, loss of oil, and shrinkage of the patty in size and in weight. Well, the textured soy protein absorbs the water and the oil and holds it. and the loss in cooking is little or minimized. We're looking at a 30% textured soy extended burger, and it is after grilling. You can see the grill mark. You can notice that the burger has retained its shape and its plumpness. Textured soy can also be used in comminuted meat products if there is no restriction from authorities. For example, the amount of soy protein you can put into sausages in the United States is controlled by what is called a standard of identity. But in many places overseas, there is no limit. So therefore, you can put as much textured soy as you can without compromising the quality of the comminuted meat. You are looking at a sausage product in which there is 30% extension with textured low-fat soy flour. We have been talking about extension of meat, but textured soy is not necessarily used only for an extension. It can be used as a replacement or as an alternative to meat, where you can eliminate the use of meat altogether. You are looking here at a vegetarian entree where it is topped with cooked textured soy pieces. I think that brings us to the end of the presentation, and I thank you for listening.
Thank you, Dr. Wijeratne. I really enjoyed that. You have a very clear and lucid presentation style. I am embarrassed to admit that I failed to introduce you properly, and since you have such a strong background, I'm going to do that now. Wilmot Wijeratne, Ph.D., CFS, has 15 years experience in research development and technical services working to expand utilization of soy protein and pulse legume products in the non-GMO and non-solvent space, as well as in food product, process development, scale-up, and commercialization. He has 5 years experience in grain legumes, food plant development, and 5 years in hands-on food manufacturing operations. He has a specialization in non-conventional technology for soybean processing for human food, as well as knowledge and experience in current good manufacturing processing and practices in food processing. He has 10 years in technical support to sales and marketing of food grain processing equipment and 12 years of university experience with roles in applied research, international food technology, training, and technology transfer based on soybean foods. His expertise also encompasses grant writing, project development, and implementation in academia and the private sector, organization and conduct of international training programs in soybean processing, and technical writing. Dr. Wijeratne has provided technology transfer, consulting seminars, and conferences in 14 countries of Asia, Africa, Central South America, and independent states of the former Soviet Union. His professional affiliations include Institute of Food Technologists, IFT, and we are happy to say he's also a member of the American Oil Chemists Society. So thank you very much for your patience with me. There are a number of questions. So Dr. Wijeratne, I will start with the first one if you're ready. The first question is, do you think the retention time of 30 seconds in the extruder is long enough to reduce trypsin inhibitor activity significantly?
Yes, the answer is yes. And how we arrived that is in the original development of this concept. By the way, we mentioned that the concept actually was conceived at the University of Illinois Department of Food Science and Human Nutrition, where I was on staff at the time. And the concept is that there is a balance between the activating or passivation of the trypsin inhibitors and yet retaining the quality of the protein. Because it is possible by extrusion to overcook soy protein to the extent that you begin heat damaging the soy protein. So the concept is that you have to have the heat process, that is the temperature profile and the duration time adjusted so that you deactivate the trypsin inhibitors to the extent of 90%. In other words, compared to the original content of trypsin inhibitors, you have to bring it down by a factor of 10-fold. At that time, you have this happy balance, the sweet spot between trypsin inhibitor deactivation and yet protecting the quality of the protein. Now, 28 to 30 seconds is the average residence time, and this has been tested over and over, and we found that the product is meeting the criteria that are desired. A lot of this work was done in swine models at the Iowa State University, and many studies are there to back this proposition. That answer your question?
Thank you. That's a very clear and focused answer. And I can only imagine that 30 seconds it's kind of a narrow edge, right? I mean, if it's 40 seconds, you're over, and if it's 20 seconds, you don't have enough. So that's got to be probably have to focus a lot. So thank you. The next question is, and this is a question that I was wondering about myself. It's about making the TSP. And it says, is there a preferred oil content in the soybeans for making TSP?
The original conventional wisdom was that you cannot make textured soy with anything but solvent extracted soy protein, because it was then, time ago, the idea that any amount of oil in the protein will not be able to make a textured product. Well, subsequent work, continuing research, and a lot of efforts have disproved that notion. What is really required is not so much how much oil there is, but how much work you can put into the protein to re-engineer that protein, which is amorphous, into a textured form. Now, oil plays a negative role in the sense that more oil you have, more difficult it is to get work into the protein during the extrusion process. So in the dry extrusion system, all of our efforts lead into texturizing the low-fat soy flour with 6 to 8% protein has been concentrated on designing the system and the operational parameters to be able to get enough energy into the protein so that they will texturize despite the fact that there is oil present. And today, it is pretty standard to have low-fat soy flour at about 8% protein made into a texturized soy product.
Interesting. Wow, that sounds like you had to do a lot of work to get there. Here is a very interesting question. It's actually two parts, so I will ask both parts, and then I can repeat the second part if you get really focused on the first one, which happens to me. So the first part is, have you ever measured the protein digestibility of textured soy protein? And isn't the protein denatured after the two-step extrusion process?
Yes. Protein dispersibility is not a regular quality control measurement in the production production flow. But in terms of developing the technology, protein dispersibility index is measured. It is not a simple test to do in a production line, for example, but commonly the urease test is done because we can get rapid results. But to answer your question, do you determine or measure protein dispersibility? Yes, because many customers that are using the product are interested in the content and quality of the protein. And remind me the second part of the question.
Right. The second part was, isn't the protein denatured after the two-step extrusion process?
There is a difference between denaturing and destruction. So denaturing is not necessarily a complete negative. For example, in the first primary process, there is partial denaturing that opens up the globular protein into a laminated form. So that is desirable denaturing because that exposes the protein molecules to action by the digestive enzymes. But the notion that the second process brings about a destruction is not accurate because we still retain, in spite of a second process, we still retain desirable protein dispersibility. We like to maintain the protein dispersibility at about 15% and not go way below that, because then we are giving too much heat treatment.
Well, you made a very interesting comment about digestibility. And I was also kind of wondering about, is it common to measure the digestibility of the proteins after extrusion? I know it's a very difficult assay because it usually involves feeding. So it's not something you do online. Is it common to measure the digestibility too of the process?
Digestibility is measured again in process development. And it is not a routine test that you do, but protein digestibility is measured using animal models.
Yeah, so it's expensive and it takes a lot of time. And then there are, of course, always the difficulties of working with animals. And then there are the ethical concerns. If they're feeding things and killing them, then there are concerns about that people don't like. So digestibility is always a very difficult question. We don't have a really good non-animal model for digestibility yet.
There is not, in my opinion, a non-animal method.
Well, that's very clear. Well, another question. When you have 6 to 8% oil remaining, how stable is the product, or what is done to prevent oxidation of the oil?
Okay, in the original development of this method, one of our major concerns was what is this residual oil going to do in terms of the stability of the product? And I reported already in my presentation that the shelf life of the textured soy protein is better than 1 year. And so the question is very relevant that you ask, how come if you have so much oil? Well, the answer that we've come up with by the work that has been done by so many different parties is that even though the oil is present in the textured product, it is not freely available for access to oxygen. For example, one of the characteristics of extrusion technology is that it is an excellent method to encapsulate a minor ingredient in a major ingredient. And in this process, what happens is that the oil is encapsulated within the protein matrix, that it is not available to attack by oxygen. And that is the reason that we give for the stability of the product.
Interesting. That's very interesting. Um, I have another question here. Uh, if you have time, uh, so what combinations of processing conditions provide the strongest passivation of anti-nutritional factors like trypsin in the screw pressing of soy?
Okay, so passivation or inactivation is a function of temperature
Mm-hmm.
and time. It's an age-old uh, theory that you bring about deactivation of trypsin inhibitors, any enzyme for that matter,
Mm-hmm.
by the application of heat. It's a function of temperature, time, and moisture. So the right combination of moisture, temperature, and time will give you passivation. And that is what we have found out in development of this process. We carry out the process at about 8 to 10% moisture in the beans. We do not
Okay.
add any external uh, moisture.
Hmm.
But in that moisture environment, we give the heat treatment, and the heat treatment was standardized after many months of work. And the conditions that we recommend for a particular extruder is developed by many months of experimentation at different temperature regimes.
Wonderful. Well, thank you, Dr. Wijeratne. You've been very educational. Obviously, you would be a very good teacher, and I really enjoyed that. I really appreciated your presentation. So, thank you very much, and I hope you enjoy the rest of our seminar.
Thank you, Scott.
Next, we are going to have a presentation by L.J. Grobler. Dr. Grobler works for CFAM Technologies in South Africa. He is the director and the founder of CFAM Technologies, Pty Limited. He started in 1998 with the development and localization of a twin screw extruder for Africa. His company, CFAM Technologies, was founded in 2007 and is today still the only manufacturer of twin screw food extruders in Africa. CFAM's extruders are in operation on 4 continents. Dr. Grobler is also professor in mechanical engineering at the Northwest University, that's NWU. He focused his research on extrusion, advanced manufacturing, and energy. In 2007-2008, he was the president of the Association of Energy Engineers, AEE, based in Atlanta, USA. He was the first non-American to become president. He also founded the Southern African Association for Energy Efficiency in 2002. He was a board member of that organization from 2002 until 2012. In 2016, Dr. Grobler was inducted into the AEE Hall of Fame. He has been registered as a professional engineer with the Engineering Council of South Africa since 1995. Dr. Grobler earned his Ph.D. at the University of Pretoria, South Africa in 1995. He also received the Lifetime Achievement Award during the ETA Awards in 2010 in South Africa for his extensive involvement in energy efficiency through measurement and verification. Now, today, his talk is called Processing of Safe, Affordable, Nutritious Foods from Locally Processed Agricultural Products Using Extrusion. I would like to remind you before we continue that if you have questions for Dr. Grobler, please enter them into the chat. And if you have questions for the panel discussion at the end, also please enter those. Dr. Grobler, thank you.
Thank you, Scott. Can you, Amy, am I online? I just had a short glitch on my side.
You are live and just fine. Go ahead.
Thank you. Good morning and good afternoon, everybody. I'm here in South Africa. It's currently 4:45 in the afternoon. So my presentation is focusing on processing of safe, affordable, nutritious foods from locally produced agricultural products using extrusion. And just to give you a little bit of a content I'm going to talk about is really focusing on our company, just to give you a short background of where we come from, and then giving some background on the challenges in Africa, what we faced with, how we can use then extrusion in terms of solving the problems of Africa and in many developing worlds as well. So that is our focus. Just this is where a view of our facility, and I'm actually sitting as we speak in this facility building here. So we are just on the outskirts of a town called Potchefstroom, which is about 2 hours drive from Johannesburg in South Africa. And this is our facility that we're operating from. Main thing is I'm mainly focusing today on our extrusion research that we've been doing and how that is applicable to Africa. So in our extrusion center, we do product development on a daily basis where we look at different type of grains, pulses, cereals, name any kind of grains, pulses, cereal that we have tried to extrude it. And if there's a new one coming along, we will also try to do that. So the main idea is looking at how can we utilize grains, pulses, and cereals, and of course, soy is a big part of that, and come up with affordable, safe, affordable foods that we can use in terms of that. So our main drive in our research focus is looking at the development of affordable nutritional foods from locally produced agricultural products. And that really says a lot, because if you're looking at it, it's not only about nutrition, it's not only about agricultural products, but it's also about economic revitalization of regions, creating a market for the farmers, for the local producers. And often what we see in Africa is we have an influx or products coming in from abroad, which actually damage the local markets and damage the local producers. And that is one of those vicious circles that we are sitting in Africa often, where actually good intentions of solving hunger, giving people food, can unintentionally lead to more hunger and more impoverishment, because the local farmer cannot survive because of those products that actually are coming and compete directly against the small producers. So those are the things that we are looking at in terms of trying to find solutions for the local markets. Just some facts on Africa. There are 54 countries, 1.3 billion people, and it's growing. It's the second most populated continent in the world, and the population is expected to grow to more than 2 billion by 2015. Unfortunately, we're also sitting with some of the most poorest countries in Sub-Saharan Africa are those in the world. And we're sitting with an ever-increasing number of children that is suffering from malnutrition. And that's unfortunately lead to another condition, which is called stunting, which is really not good during your early development. Urbanization is also happening in Africa. There's a 30% growth in cities population in the world. Most of that will happen in Africa over the next couple of decades. So often people will say this is a problem, but we said, okay, then there's also create an opportunity for us to look at how can we assist in terms of where we live. So if you're looking at the needs of Africa and the world, the main thing here is coming at regional economic revitalization. How can we do local stimulation of the economies so that they can assist themselves, start to produce locally, but also in the longer term export and then create some inflow of capital and money into that region. So important thing is sustainable local supply of safe food, energy, and water. That is part of the important thing that we, and then of course with all of this job creation, that is crucial. Creation of jobs and food. Now all of this whole process is in the end boils down to strong value chains. Creating a strong value chain from the farm gate to the end consumer, the end user. And in the end, we all know a chain is only as strong as its weakest link. So if there's a weak link in the supply chain, that chain will break. And that is often what's happening in the food supply regions in Africa that we're coming with. Now, we talk about here the Africa's, that's our extrusion resources. If you're looking at where the raw material are, the grains are being produced, and I just highlighted here the different countries and the top 5 producers of all the countries of the different type of grains, which include maize, wheat, rice, sorghum, soy, cassava, millet, and chickpeas. So you can see here, they're on the southern side. South Africa is a high producer of grains. Then in the central band, there's a lot of producers of grains, and it varies between maize, sorghum, soy is important. Zambia, there in the central, all these central countries actually produce soy. And then, of course, we have the GDP. And then if you look on here side, the population split between male, female, and then the years, we can see Northern Africa, Southern Africa has more a matured kind of population that you expect, where the Central Africa, East Central, and West Africa, very large component of kids, young kids coming through, which shows us of the growth in the populations. The biggest growth in population will be in the Africa Central Band. And so therefore, that's where the need for food production and safe, affordable foods will be for the next coming of years. So looking at the nutritional value, and this is just an illustration of what is needed. Our body need all the different nutrients, macro and micronutrients, and good nutrition leads to optimal brain development, great health, and ultimately thriving communities. And it's so important to make that connection between nutrition and thriving communities, because poor nutrition leads to stunting, which inhibit actually your brain development, which has a massive impact on you over the long term. So for communities and so on, getting the right nutrition is crucial. So for us, where we look at from a development point of view, is looking what is needed by the body, and then also taking what is available on your grains and your natural resources. So taking your natural resources, putting that through an extrusion process, doing necessary fortification with vitamins and minerals will lead to a safe, affordable, nutritional food. So that is the main thing that we're sitting with. Also on this side, which is very important in the process that we sit with, as the previous speaker has mentioned, extrusion, we're talking about a quick, high temperature, high pressure cooking process of 30 seconds. That's typically that you're looking at. And that importance of this process is also that if you're looking at the natural grains that you process, running at the process where in some of the products we run of pressures up to 160 bar, 160 bar. That is quite high pressure. You're sitting at temperatures ranging between 120 to 160, some products ranging up to 180 degrees centigrade. Of course, that's not Fahrenheit. So that means that the product that is really extruded under these conditions, and it is properly, this process under good control, it means that that product is sterile. And more and more companies and countries are starting to realize that extrusion is actually a preserving process as well. So if you're looking at your grains, in grains, you are more than 99% guaranteed that all grains in the African environment will be infested with some kind of insect. And it's just how you treat it and so on to prevent that from spreading. That's the important thing. But once you've extruded the process, that product is actually sterile and clean. And all that you need to do is ensure that it doesn't become contaminated afterwards. And this is really the whole process why extrusion, we feel, uh, is so suited for Africa in terms of providing safe, affordable, nutritional foods. It is actually, with the latest development around extrusion, also possible to actually provide a basket of extruded products where a person can only eat extruded products for breakfast, for lunch and dinner, and have a large combination between cereal porridges in the morning and cereals, and then meat analogs, meat products for lunch and dinner. So thus having a complete balanced meal, and together with fortification on your vitamins and minerals, you can actually provide a fully balanced meal that provides your recommended dietary allowance. So our intent in looking at our research, our development, is focusing on, first of all, how can we assist in food security and assist in a sustainable development environment, and also then using technology and innovation actually to solve and assist the continent in terms of its challenges. And that is where we've been working, therefore, on all these nutritional foods from locally produced agricultural products, and that's been our main aim. There is also another big bad wolf around here, and that is global warming. And up to now, most people have thought about global warming is mainly an issue around energy, around emissions associated with energy. But as Project Drawdown is a most comprehensive plan that was released by United Nations General Assembly end of last year. They came up and they've identified a range of mitigating factors for climate change. And what was very interesting out of the study that came about is that apart from refrigerant management, wind turbines, which are the number one and two mitigating factors in the world, number three in the four that can be used to mitigate climate change are actually reduced food wastage and plant changing towards a more plant-rich diet, where the other things like solar farms, rooftop solars, those things that people most of see are the solution for mitigating climate change, actually food industry is number 3 and 4. And that is some very insightful things that came in. Now, this has created, of course, if you look at where it's coming from in food production and emissions, we've been realized actually came in that in the world, about 17 to 18% of all global emissions in the world are attributed to feedlot. And of course, one of the biggest ones there is beef production. To produce 1 kilogram of beef, you emit about 13.3 kilograms of carbon dioxide. And this is the same as burning 6 liters of petrol. So this is the equivalent 6 liters of petrol or gasoline that you will talk about, that has the same amount of emissions than producing 1 kilogram of beef. And this is the main drive why, if we start looking at moving away from meat-based protein to plant-based protein and diets, that will result in a 90% emission savings of carbon dioxide equivalent. And that's one of the main reasons why people are becoming so conscious of moving away towards plant-based diets. If we're looking at the extrusion process, and our previous speaker touched on that as well, we're sitting with the raw materials of grains that's been coming in. That is need to be pre-processed. Pre-processing normally include cleaning of it, bulk handling, milling, mixing, weighing, blending. That's the pre-processing side of it. And then we're sitting with the extrusion process, which is basically then, and we focus on mainly twin screw extruders, and then, of course, single. So you're sitting with the extruders doing the cooking. And the reason why we're looking at these type of products are the grains, pulses, cereals in general. We as humans cannot digest those products in a raw format. So it has to be cooked, and then it became digestibility for us as humans, so we can consume it. And then post-processing of those products normally entail cooling, drying, coating, milling, sieving, packaging, depending on the type of products that you do. But the applications then ranges from a wide range of products, from porridges, cereals, breakfast cereals, snacks, and even pet food, aqua feed, so in the animal environment, some of the animal feed environments. That is where we're coming from. So if you look at the whole value chain, and if you're looking at the value of extrusion in the region, basically what we sit with is we're sitting, and we came up with what we call the extrusion sustainability circle, or basically a circular economy around extrusion. In the end, if you're looking at the energy flow, we have the energy coming in from the sun that assists the producers. We have our grains being produced. That's go through a storage process. And then we have the processing side, where we're sitting with the extrusion processing, doing beneficiating it and making that product, cooking it so that it becomes available for us humans to consume. Then you have your distribution center system, taking those products to the end consumer, which could be people, could be fish, could be dogs, those all people. And in the end, you have, that is your energy flow, because all of us, we consume those food to get energy. So that's, in the end, that energy came from the sun. And then you have your circle that complete the whole process, which is the monetary circle that goes back and basically feed the whole circle. And then this process just carry on and on. And with more energy coming in from the sun, this thing can actually assist itself and grow in the end. And that circle becomes more and more sustainable. So this is in essence what you talk about. And in this whole process, you're creating jobs, you're assisting alleviating poverty, it leads to economic growth, local beneficiation of the local produce, food security, and then the main thing on the environmental side, energy efficiency. Extrusion is the most energy efficient cooking process currently still available, because that energy that you generate, that you create to cook, at that heat is generated through friction at the point where the cooking is needed. Where other traditional cooking processes, heat are more added from the outside, and then more heat is lost into going into steam or other process. So that's from an efficiency point of view, it's the most efficiency cooking process currently still available. And then of course, you have your reduction, and it's a clean process, good production process that we're sitting with. So for these plants, you're sitting with various sizes of these plants from various sizes. This is just to give you an indication of some of those plants in the region that we've set up. Going to the inside, you can see it's quite a sophisticated plant from, if you look at it initially, but in the end, it's basically a fairly simple process, very stable, matured process that you can use to actually process. Capacity ranges from 100 kilograms per hour up to 10 tons an hour. And if you want to go more, you can go, just put more plants in parallel and more machines in parallel to basically go to any type of capacity that you would like to go to. That's possible. Extrusion products, just to highlight, although we're talking about soy, the main thing is it's various type, all the type of grains is actually applicable and can be used in it. And this is where the soy really comes in. Soy is an ideal product to be combined with various other grains, various other starch type of products to give you a good balanced diet that you, for different types of formulation and products that we're looking at. So this is the opportunity really where it comes in. If we're looking at extruded products on its own, there's quite a wide range of applications. So coming in from the normal basic one, we're looking at breakfast, porridges, world feeding programs, looking at taking soybeans, combining that with a starch, either maize or rice or wheat, and coming up with what we call corn soy blends or wheat soy blends or rice soy blends, which are then a more nutritional products, going towards the texturized processes where we have either dried texturized products and even lately wet texturized soy products, which then of course need a cold chain. So the opportunities really of using extruded soy food products are immense. And then as the previous speaker mentioned, also taking that into patties, hamburger patties. And these products that you actually see here are 100% vegetarian. So we're looking here having a soy-based product, 100% vegetarian. And that's a product basically in its raw format. And after you prepare it, you've grilled it, this is how it looks. So in the end, you can have total vegetarian products that behave like a more meat-like product in the long term. Yeah, then also some new developments. These are all products we are starting to come in on more the upper end of the market, where you have various type of products, all vegetarian, soy-based products. So that's the nice thing about the latest developments around where we're sitting. It is not only a low-level market entry. These are also high-end market products where you can use the soy in terms of that where we're coming in. Just like in terms of the extruder ranges, I have to show you a typical, our previous speaker also alluded to that. How does an extruder basically work? And if we look at the extruder, we're sitting with a main hopper where we have our mix prepared and then feed it into the system. Some extruders will have preconditions depending on the product, but on the soy side, we most of the time have a precondition where we do steam preconditioning, adding steam to the process, and then the process going through the barrel where the cooking and then going for the cutter and die for the final forming process that we set. So in the end, taking a raw mixture, and that is prepared depending on the type of product that you want to make. So, and you can mix it with grains, cereals, and pulses, mix those products, mill it, prepare it, and then send it through the extrusion process, having a final product coming through the cutter and die assembly. And then at the cutter and die, it can be formed in various types of shapes and sizes and so on, from kind of a cereal things, bran sticks, crispies kind of things, or puffed snacks. And once again, you can play around with the shapes and sizes of their products. That's the benefit. So one of the benefits, main thing, if you're looking at extrusion, is first of all, it allows us to produce safe, nutritious, and affordable foods. And as the previous speaker alluded to it, we can, on a dry format, without having a cold chain available, just under normal atmospheric conditions, produce these foods, sterilize it as part of the extrusion process, and then ensure that it's properly packaged and you have a product with a shelf life of more than a year. The other benefits of the extrusion is you can use local beneficiation and local produce. And I think this is really the opportunity for Africa, is to assist and using extrusion to local production, local beneficiation. From our side, we are the only manufacturer of this in Africa in terms of twin screw extruders, and assisting then in creating a value chain from the farm gate to the end consumer. And that assists really in creating local economic development, creating jobs, and as I mentioned to it, it's an energy efficient process, continuous cooking process with no waste streams. And that's one of the biggest benefits also of extrusion compared to other traditional cooking process, where you always have some water effluent, water treatment that needs to be happening here. There is none like this. So in the end, you utilize all your grains coming in, utilizing that, so you don't have any waste streams or water treatment that is needed afterwards. And then lately also the big drive towards more plant-based diets becoming actually one of the biggest mitigating factors of climate change. And that is something very interesting, which will, of course, drive the whole process going forward. You know, and if you're looking at Africa's challenges that we sit with, we always have challenges in grain quality, changes in cultivars, and that's my products very sensitive to in terms of quality and consistency, these changes. Where if you go for something like extrusion, and specifically twin screw extrusion, you can actually mitigate some of these changes with the processing processes that you have. Milling particle sizes, lack of consistent supply, poor distribution of milled products, dump products, and poor grain quality are all issues associated with Africa. But having then systems like a twin screw extruders, which are more prone to handle variances of these conditions and still be able to have a more stable, consistent product, enables you to actually assist small emerging farmers and so on to actually process their grains, because one of these challenges are mainly associated with smaller subsistence farmers, emerging farmers in the region. And this is where extrusion, and specific twin screw extrusion, can assist in that process. So yeah, in conclusion, we think extrusion is an ideally suited technology for Africa and developing countries, and combined with fortification of micro and micronutrients, we can actually produce food products that meet your recommended dietary allowances. It's cost-effective, robust technology, effectively being a mature technology in the region. And new developments lately on specific twin screw extrusion provide also opportunities to produce plant protein that are comparing very favorable with meat products, and then those products being completely plant-based. So that's the opportunity actually then opens up. And we see that extrusion can play a significant role in revitalizing Africa's regional economies post-COVID-19. Where there's really the continent has been hard hit by COVID-19, not necessarily due to the disease as well, but due to the trade restrictions and that was imposed on the region, and well, also globally. Many countries has a low infection rate, but a very large impact due to the COVID pandemic economically. Yeah, and that's it from my side. Thank you very much.
Thank you, Professor Grobler. That was very informative. I especially appreciated how you were able to both talk about the larger scale impact across the culture and then bring it down to details about impact on people and details to some measure of actually how the process works. I have a number of questions that have come in, so if you don't mind. The first question is, why are twin screw extruders preferred over single screw extruders in developing countries?
Traditionally, people have more been prone to use single screws because it has been an older technology, it has been there. But latest development in twin screw has actually enabled twin screw also to get traction in the developing countries. The main difference between the two technologies are that the twin screw extruder operate more like a positive displacement pump. You have twin screw air compressors. You can actually compress the air with twin screw extruders. So, and that gives you the ability then to have a machine where you can fix your flow rate through the process and then change the other conditions. And that means the process is not so much prone to change with variations in particle size, variations in grain qualities, and so on. Where a single screw works on friction only, and there's only one point where that whole system stabilizes. So if you have a certain stability point and you have a small change in, let's say, moisture content, then the whole process changes to stabilize at a new condition, or a change in particle size, and then the whole process changes. Now, these things varies actually as the machine is running. Particle sizes, distribution is not exactly the same everywhere. And that is actually where we feel twin screw has the opportunity to actually give you a more stable, consistent product, although your input conditions vary.
Very clear. Thank you very much. Here's a question. The question is, can we extrude cereals, legumes, and soy with a single extruder, or do we need different screw configurations to treat each?
On the single, you can actually, normally what we do is you can use the same extruder to process all of these. What you do need is some for different products is to change your operating parameters and your screw profile, so your screw segments. And that's why the more economical and convenient way of designing these systems is to have segmented screws. So therefore, if you change from a pulse to a cereal to a grain, basically you change, just pull out your set of screws, put in a new set of screws, and you can actually within an hour change from running on a chickpea, running on maize or wheat or soy. So that interchangeability and flexibility is also much easier on a twin than on a single.
Interesting. Here's a question about mycotoxins. So there are actually two questions, and so I'll read them one after the other. First, more specifically says, can an extruder remove mycotoxin from corn? And does extrusion mitigate aflatoxins that may be present in mixes with corn or other commodities?
Okay. If we look at the whole process around what we do is, just me stop this whole thing right here. There's some. So what we're sitting with, sorry, there was some alarm coming off on my side. So what we sit with, if we're looking at mycotoxins, for example, aflatoxin specifically, which is a huge problem on maize and corn in Africa environment, extrusion does break down aflatoxins, but it doesn't eliminate it completely. So there are some tests and trials have been literature showed that aflatoxin, you can break it off about to 90% quite certain, but you cannot say it break it off completely. So in terms of looking then at processing plants, what is important is to look at how can you remove aflatoxins before and then process it to get to aflatoxin levels that are acceptable. So what we normally do in terms of a processing plant like this is we will combine a processing plant where you'll put in a optic sorter that you actually do a sorting of your maize, and you use it by optical color sorters. And by doing that, you can remove the highly contaminated products before the extrusion process. And then sitting with the products, of course, you cannot eliminate all of that. But doing that, you can really mitigate the problem significantly in terms of using products that are infected with aflatoxins and so on to actually be able then still to have a product that meet the recommended levels.
Yes, the whole question of aflatoxins is vexing some years, and other years it's not quite so bad. So you have to be very versatile. Here's somebody who asked you if you have experience extruding fiber-rich products, and can you comment on that?
Yes, we've done actually about 2 weeks ago, we've extruded brewer spent grains. Now, if you're looking at the fiber-rich product, brewer spent grains, there's a lot of fiber into that. So the main thing is looking at fiber-rich products, and for example, another one is wheat bran, also high in fiber. If you're looking at wheat bran extrusion. So all of that we've done is possible. The main thing that you sit with, once again, on the extrusion of that is often, if the fiber is too, what the fiber do, it's actually keep your product intact. So you can't get expansion that you normally want from extrusion process. So but if you start taking a fiber-rich products and mixing that with grains like rice or wheat or corn, then in that combination, once again, can give you a very nice mix of products. And in that instance, even taking brewer spent grains, you can actually make a very nice high fiber snack from combining brewer spent grains with a product like corn or rice.
Interesting. That's great. Here's somebody who wants to know if they can design inexpensive extruders and what it would cost. It sounds like they want to make their own.
Yeah, that is always the difficult one in terms of what you're looking at. Inexpensive extruders equals, unfortunately, most of the time to short extruder life. If you're looking at a processing site where you're coming in, you're looking at equipment operating at very high pressures, 160 bar pressure. So if your system is not well designed, and most of the time those expensive things are your materials, specialized materials, you can't use just normal ordinary mild steel and just normal stainless steel. It's not good enough. You don't get durability out of that. So, and then your gearboxes, truss bearing packs, those are the things that don't last. You know, a proper extruder is designed and built to operate 15 to 20 years. And then it's a very profitable investment from that point of view, where cheap extruders tend to last 1 to 2 years, and then you have to replace it. And if you look at the financial feasibility of an extrusion plant, you know, the cost of an extrusion plant, you know, a extrusion plant will generate annual revenue of 4 to 5 times its initial cost per year if it's fully utilized. So therefore, initial cost isn't really the thing that you need to look at. It's the lost opportunity cost of having extrusion plants standing for weeks and months because you have critical components that failed and was not properly designed.
That makes a lot of sense. The last question here is, do all materials need to be dried before extrusion?
That's a good question. In terms of where you operate, it all depends on what is the moisture content of the product. Yes, from extrusion point of view, the primary process requirement is we need friction. And that friction is created by internal friction between the particles of the grains, pulses, whatever we extruded. So if your water content is too high, you don't get enough friction, which means you won't get proper cooking. So, and that is the limiting factor. So often what we do is if you sit with a product that is high in water content, and there, for example, we even talk about meat processing, we sit with 70% water, then you will tend to take that and mix that with a grain which is dry, getting a more drier mix of drier products versus non-dry, and then extrude it. And it can be done. But only extruding product with a very high water content, then you're defeating the purpose of getting the heat generated from friction. That's the main primary reason why extrusion is so cost effective. It's generating the heat through friction. Once you've lost that, then you've lost the economic feasibility really of the extrusion process.
Well, thank you very much. Fascinating presentation, and obviously it's the kind of topic that requires many years of hands-on experience. So thank you for sharing yours with us today.
Thank you, Scott.
Please remember, if you have questions for our speakers, into the chat feature, enter them there, and we can ask them after each talk. And of course, if you have a question for the panel, you can also put those in the chat, and it's helpful if you direct your questions to the speaker that you would like to have answer the question first. Dr. Mugabe sent his regrets because he had an unforeseen conflict. It prevented his attending. So now we're going to see presentation from Professor Marcela Gaytán-Martinez entitled Development of Snacks Enriched with Legumes and Cereals Obtained by Extrusion. So Professor Gaytán-Martinez works at the Universidad Autónoma de Querétaro in Mexico, and she earned a master's degree in food science and technology at the Universidad Autónoma de Coahuila. Later, she completed a Ph.D. in advanced technology at the Instituto Politécnico Nacional. She is currently a research professor in the graduate program in food at the Center of the Republic Research and Graduate Studies in Food Science, School of Chemistry, Universidad Autónoma de Querétaro. Dr. Gaytán-Martinez is recognized as a National System of Researchers Level 1 and PRO-DEP profile. She teaches and researches in the food science and technology area. She has experience in the development of food products using emerging technologies, in innovation in product concept development, formulations, and prototypes from cereals. She's published more than 50 articles in high-impact journals, book chapters, human resources training on the bachelor's, master's, and doctorate level, and also intellectual property registration. She's also participated as a reviewer for journals in the food industry and in the development of products and processes suitable for technology transfer. Again, the title of her talk is Development of Snacks Enriched with Legumes and Cereals Obtained by Extrusion. Professor?
Good day. Thanks for the presentation and thanks to the organizing committee for the invitation. I would like to talk about some of the research we have done. First of all, I would like to start to talk about innovation. Talking about innovation means talking about a multidisciplinary field of study. The result of the innovation is a process known as a product that satisfies each consumer a specific desire or need. Innovation occurs when a product is improved. The improvement can be in its physical characteristics or in its use. In research use, it has been considered that it is the user who directs the creative process that leads to innovation. In other words, it is the need or demand of users that can be identified, captured, and become requirements for new products capable of satisfying such needs. To make these changes in the product requires the understanding of technologies and markets, calling this whole process innovation. Understanding the market dynamics is important and must be done from the consumer's perception. Design thinking is a widely used tool in innovation. This methodology is useful because it provides the variables for a product to succeed in the market. This is the base for understanding the user, what they think and feel about the problem, being this an active part of the creation process. Design thinking consists of 5 main stages. The first one, the emphasizing phase, involves understanding the user's needs, which can be presented implicitly or explicitly. In the definition phase, problems are identified whose solutions are vital to obtaining an innovative result. The idea phase consists of generating ideas for possible solutions to the problem identified. The prototyping phase consists of making the ideas paperable. It is a phase in which the possible solutions to a problem to be solved are visualized. Finally, these prototypes can be evaluated with the user to determine whether they meet these needs. Traditionally, this food industry includes the consumer in the last part of the development process, during the validation of a product to guarantee its acceptance in the market. In case it is not accepted by the consumer, the prototype must be returned for considering the consumer observations. Design thinking perceives the consumer's vision as a starting point for the entire development process. Snacks. The variety of snacks refers to the type of food, the size, and variety offered in the market. Snack consumption has been modified around what people eat. Customers are now regularly incorporating snacks, blurring the line between what is a snack and what constitutes a meal. The idea of a snack as something to be consumed between meals has changed completely. With chaotic schedules and less time to prepare meals, our current lifestyle has often put snacking in place of food. Therefore, the snack industry has been in constant growth over the years and continues to occupy an important place with the total food trends. It is one of the categories with more remarkable growth in the domestic market for its high availability, finding them in a large number and variety of establishments. The snack world market is valued at $266 billion. It is expected to grow at 2.7% annually until 2022. Currently, the market options have evolved, becoming more specific. Today, snacks are being redesigned to increase their nutritional value, adding micro or macronutrients, phytochemical components, vitamins, antioxidants, and other ingredients that make them attractive to the consumer, known as snackification. Consumers select a snack by its flavor, chili, cheese, and others. The healthiest and most nutritious products are having a significant impact on snacking choices. Another important aspect is that consumers see snacks as an essential part of the fun. That is to say, when watching television, at a party, with friends, snacks cannot be missing. Worldwide, except for hunger, the main reason for consumers to eat a snack is for pleasure or reward. Snacks are available, so with today's pace of life, it makes it easy to access. Cost and brands are two factors that influence but are not definitive in the purchase of decision of snacks. Snacks can be classified in various ways. However, from the technological point of view, the snacks are classified into three generations, according to their elaboration techniques. These are the conventional products made from whole grain using moisture-temperature combinations. In this category are natural products such as nuts, chips, and popcorns. First-generation snacks show the significant disadvantage of perishable raw materials, which places these products with a concise shelf life. These are products in which the raw material is involved in different preparation stages to obtain a dough, which is then subjected to baking process to obtain the final product. Most snacks fall into this category. For example, corn tortilla chips, corn kernels, and all directly expanded products. Second-generation snacks include single-ingredient snacks and directly expanded snacks. They do not require transformation to complete their expansion after extrusion. Once this step is completed, the products can be finished by baking or frying. The directly expanded products do not require additional operations to the extrusion for the expansion. This process is straightforward, and the products achieve these characteristics through a temperature-moisture ratio, which causes the product to expand once it reaches the extruder nozzle and has contact with the outside. Third-generation snacks are known as snack pellets and half products, similar to second-generation products, although the product obtained is not ready to be consumed. Their final presentation is usually after frying in hot oil or expansion. Due to their higher storage stability and high apparent density, third-generation snacks present an attractive potential market. There is a variant of the original third-generation snacks as the expansion can be carried out by microwave or hot air. Most snacks have low nutritional value, a high amount of fat and salt, so they do not constitute a healthy food. Despite this, it is an industry that covers various markets. Therefore, successful innovation is the key. Today, snacks are being redesigned to increase their nutritional value, adding micro or macronutrients, phytochemical components, vitamins, antioxidants, to mention a few ingredients that make them attractive to the consumers. Besides, the process for obtaining the snacks must change. So the market for air-baked or air-expanded snacks has increased, which significantly increased the fat content. However, this implies a great challenge because the snacks must be nutritious and have a high sensory acceptance. The snacks are obtained mainly using cereals such as wheat and corn. However, non-conventional cereals such as sorghum and amaranth can be used. On the other hand, legumes consumption is essential both in nutritional and sustainable agriculture. Legumes are an essential source of protein, fiber, vitamins, and minerals, easily accessible because of their availability and low cost. Within health promotions for obese or undernourished people, increasing the daily consumption of legumes and whole grain cereals is considered. The most consumed legumes worldwide are soybeans, peas, beans, chickpeas, among others. Legumes are essential because they are the natural source of vegetable protein. The combination of cereals and legumes allows us to have higher protein content. It improves its amino acid profile since cereals are deficient in lysine and tryptophan, while legumes are an essential source of this. Another thing is that cereals are an essential source of fiber and bioactive compounds. Food extrusion is carried out in a bioreactor called an extruder, where high temperature and short times are applied. Extrusion is a growing technology due to its high continuous process capacity and energy efficiency. Its versatility and capacity to change the product's intrinsic taste, texture, and structural characteristics made it widely used technology in the food industry. Two types of extruders are commonly used for food processing: single-screw extruder and double-screw extruder. Single-screw extruders are the most widely used in the food industry. In these extruders, the product transported by the effective material drag that occurs when the friction of the material on the internal surface of the cylinder is greater than the friction of the material on the surface of the screw. There are three main areas in an extruder: feeding, heating, and shaping. Our team has specialized in developing extruders for specific applications that are accessible and affordable. Feeding zone is the zone where food is introduced, and its main objective is to compact the food in solid form and transport it to the next zone at a certain speed. Heating zone consists of two parts: a pre-cooking and a cooking zone. In this zone, the compression is also carried out. It is the final zone in which the material is compacted. It is in the zone where the material is melted and homogenized. Shape zone. This zone corresponds to the last part of the extruder where the cooked material is homogenized and pressurized towards the outside, employing a die that also shapes the product. Extrusion carries out several unitary operations and transformations such as flow, heat, mass transfer, cutting by mixing, particle shape reduction, melting, texturizing, caramelizing, plasticizing, shaping, forming, among others. The extrusion process presents multiple advantages, the main one being its versatility, since, as previously mentioned, several unitary operations are carried out such as mixing, sharing, cooking, drying, and texturizing. It is a processing method that works at high temperatures and short time, and is capable of preserving desirable food components and destroying microorganisms. Another advantage of using extrusion is low operation cost. The advantage of extrusion is that it makes it possible to produce foods with various shapes, colors, flavors, and textures from basic ingredients. Besides, it is an environmentally friendly technology, since it does not generate contaminating influence. Development of protein-enriched third-generation snacks. Within the food products manufactured by extrusions, snacks has been successfully incorporated because this technology has allowed extending the range of food in the market. The extrusion has been used to produce second and third generation snacks from cereals and enriched with legumes. These can be baked or expanded with hot air. We use wheat and chickpeas to obtain pellets, which we will expand with hot air. The physical characteristics of extruded products are achieved by the properties of the feed materials and by extrusion parameters such as moisture content, screw and die diameter, temperature, screw speed, and feed rates. Therefore, we first determine the chickpea content that could be incorporated into the formulation. Then, evaluate the effect of extrusion temperature, and then moisture content that was used during processing. We observe that the higher the temperature and moisture, the higher the expansion rate. This is because proteins influence expansion due to their ability to affect the distribution of water in the matrix and its macromolecular and conformational structure, which affects the extensional properties of extruded melts. Starch and protein fractions compete for available water in the matrix. This alters the viscoelastic properties by delaying the gelatinization of starch, which generates less moisture and affects the expansion rate. The addition of alternative ingredients with high fiber or protein content significantly affects the texture and density of the product. The crunchiness is a characteristic parameter of the texture of third-generation snacks. The best texture parameters were obtained in the snacks with the highest expansion index, which was reflected in a higher crispness as well as a lower density, which indicates a less hard snacks. The sample processed at 120 degrees and 80% moisture were those with the best expansion and crispness index. Sensory acceptance was compared using a 9-point hedonic scale with an untrained consumer panel of adolescents. It was observed that the chickpea enriched snack has a direct relationship between each of the attributes where a value of 7 was reached, for appearance, taste, and overall acceptability, and showed no significant difference with the commercial snack. On the other hand, the commercial snack reached a value of 8 for the crunchiness. The difference in crispness is due to different formulas. A snack with a higher protein content will have higher density, however, it was accepted by the consumer. Sodium is another main problem of snacking. According to the International Health Organization, the intake of sodium should not exceed 2,400 milligrams per day. The developed snack presented less than 140 milligrams per 100 grams, so it is considered low in salt. In the market, 100 grams of snacks come to provide between 426 and 2,673 milligrams of sodium. A red focus in the consumption of snacks is the high amount of fat they provide. According to the FAO and the World Health Organization, recommended intake of fat is between 20 and 35% of total energy intake, and consider that the optimum value is 30%. So for a diet of 2,000 calories per day, the snack enriched with chickpeas had 3 grams per 100 grams of the product. The contribution of protein was 14 to 18 grams depending on the amount of chickpea that was added, on average 16 grams of protein, so it is considered a good product in protein. On the other hand, we were also working in the development of a second-generation snack obtained from extruded and subsequently baked nixtamalized sorghum and amaranth. The second-generation snack obtained from sorghum and amaranth has shown to have more protein and fiber as well as less fat compared to a commercial snack. The nutritional content indicates that the snack is high in protein. Besides, it was highly accepted by the consumer. Value curve indicates that using extrusion to obtain snacks enriched with cereals and legumes allows us to obtain products with low fat and sodium content in addition to being high in fiber and protein compared to a commercial snack. Extrusion is available and economical technology for the development of healthy and second and third generation snacks. Other researchers and I have formed a multidisciplinary team so that different types of extruders have been developed that can produce products according to the needs of the industry to meet the requirements of consumers. Now we are developing snacks using other types of legumes, such as soybeans and sorghum, processed by extrusion and that satisfy consumer requirements from a nutritional point of view and have a high sensory acceptance. All the work would not be possible by working as a team with researchers from the Universidad Autónoma de Querétaro and the Instituto Politécnico Nacional, as well as by the support of pre- and postgraduate students. I hope you will visit us in Querétaro. It is a beautiful city that has a great history and is considered the origin of the independence of Mexico. Thank you for your attention.
Thank you, Professor Gaytán-Martinez, for that interesting talk about snacks, something that's near and dear to most of our hearts. A question has come in that talks about extruding with sugar. So it says, if the formulation to be extruded involves adding sugar, would the sugar liquefy? And if it does, will that reduce the friction and impact the extrusion process? Does that make sense?
Depending the composition nutrition of the product. The sugar liquid with the extrusion. But the problem is when you have sugar, for example, and protein. When you have a sugar and protein combining and develop the different reaction, this reaction can be products give food a different quality. For example, Maillard reaction, it's a bad reaction for the food, but depend what is the composition the food produce this type of reaction.
So the answer is, as the answer is with so many things, it depends.
And depends the composition of the food.
Yeah.
You can put only sugar, it's not possible. You need put a food. If the food have a different composition, chemical composition. For this is very important that every person know what is the proposited use the extrusion. Yes, this is very, very important.
Interesting. Well, here's another question. It's about legumes and pulses, and it says, could you comment on opportunities for extrusion of legumes or pulses such as lentils, dry peas, and chickpeas, and advantages or drawbacks of each of those?
The legumes have been a part of the human diet. The legumes are food that contain a high protein, which is good of the amino acid, for example, lysine and tryptophan. In addition, the legumes are food that contain other composition, for example, anti-physical factor, such hemoglobin, trypsin, amino acid inhibitors, and some other. Unfortunately, these anti-physical substances are susceptible to process temperature. The process extrusion involves some factors, for example, water content, temperature, and time cooking. I think this is a secret for obtaining good quality the food products. This combination of this factor played of the principal factor for keep a good sensory and nutritional quality products. A structure can be used the processed legumes with the different advantage. They can minimize the content and nutrition component as well increment the viability proteins. The one disadvantage is the extrusion process can be decreased. They containing some amino acids that are susceptible at temperature. For example, lysine. It's okay?
Well, thank you. And interestingly, there's another follow-on question that talks about amino acids. And of course, you know, with legumes and pulses, there's the question of the combination of amino acids to get a full nutritional, the full amount of the right amino acids. And so this question is about co-extrusion. And if you have a preferred combination of materials to co-extrude to get a complete set of nutritional amino acids.
Yes. We can combination at different foods. For example, cereal and legumes are an excellent combination to have a balance in nutrition profile of food. Cereal has a good food supply of bioactivity components and carbohydrate. However, they are a deficit in some amino acids, specific lysine and tryptophan. On the other hand, the legumes are an important sources of protein in addition to having a good content on the limiting amino acids on the cereal. Other advantage combine cereal and legume both contain bioactive components, phytochemical and antioxidant components. This is the advantage combine different foods, cereal and legume and other foods.
It is one of the big challenges to research in this area because the combinations are infinite. There could be so many different combinations of ingredients and processing conditions. So sometimes I'm surprised we ever get anything at all. Well, that concludes our questions for you, Professor. And so now we're going to switch to the panel discussion. Thank you for joining us now for the panel discussion. We have Professor Gaytán-Martinez and Dr. Wijeratne here with us today, and we have a couple of questions that we are pleased that you can address. First of all, the question is, what, in your opinion, are the biggest opportunities for the growth of extruded soy products in Africa?
That question for me.
Well, we would appreciate hearing from both of you if you have an opportunity, but you can go first.
Okay, I'm not an expert on food and nutrition in Africa, but I learned a lot from the previous presentation. But like I said in my my presentation, the biggest opportunity, in my opinion, is to figure out where we can improve the cereal-based staple diets in Africa. This most of the diets in Africa are cereal-based, whether it's maize or rice, or teff or what have you. They are low in protein. There is an energy source, but the protein source is lacking. And soybean is one of the best ways to complement the staples, cereal-based staples, to improve both the quantity and the quality of protein. And that, I think, is a big opportunity. I believe that this combination, the blending, if you will, of the cereal and soybean or other legume, can be done at an agribusiness level, fairly centralized, but it is also possible to be done at the household level by simply making the processed soy flour available to the homemaker so they can do the combination or the blending themselves on a daily basis in preparing the diet. This, I think, is the biggest opportunity that we have to improve the overall nutrition situation.
Thank you. Dr. Gaytán-Martinez, did you have something you wanted to add to that?
Yes, I believe extrusion is a prominent process in the food industry. I think in the Africa is a good opportunity because the extrusion can be combination of different legumes and cereal and other cultive typical the Africa. And this is possible developing food specific for every need people in this country. I think this is a good opportunity.
Interesting. I appreciate your answer. Now, there's a question that's come in that is about vulnerable populations like refugee camps. So after a disaster, maybe a flood or a war, and large numbers of people have to go to a place that's far from home, like a refugee camp. And it says, is extrusion a good technology for low-cost, nutritious food for vulnerable populations like refugee situations?
May I comment on that? For the refugee populations, I know there have been certain programs done in Sub-Saharan Africa, particularly in Ethiopia. We may have heard this product called plumpy nut. Now, most people that are congregating in the refugee camps, very few or little infrastructure to make or process any food at site. So I think this, in these situations, products can be processed at some central places and then made available to be simply prepared at the refugee camps. For example, I think I heard one presenter talking about instant porridge making. Now, those kinds of products can be made to have a balanced nutrition. In other words, Dr. Marcela was saying a combination of the cereal along with the legume, they can be made in extrusion centers and then distributed in convenient packages to the refugee camps, where it only involves having boiled water to hydrate this material and serve them directly to the refugees.
Thank you. Professor Gaytán-Martinez, did you have anything you wanted to add to that?
Yes. The instructional way you to have food for each group of people at low cost. It is really, you can develop products with high content, with high protein content, and with good packing, you can have a long shelf life. This is very, very important in this situation, in different situations. You can put a micro or micronutrients specific for the specific group. This is very, very important because every people need a different nutrition. This is not necessary for situation specific. All the world need this type of nutrition, and the instruction give this opportunity.
Well, thank you. Another question has come in about snacks. It says, why have snacks received such a bad reputation? And is it hard to make healthy snacks?
The snack is the snack that people thinks is a bad food, but the snack is a good opportunity for give a different nutrition or micronutrition for each people. I think the concept of the snack is changing in this moment because the people have other type of life and need a snack in different time in the day. The snack is a good opportunity for change the food industry, I think, because we can give every people a specific snack with a specific necessity, I think.
If I may add to that, the connotation of a snack generally in the mind of the normal consumer is a sort of a cereal product that has been expanded to be very crunchy. So they are more like comfort foods. But there is a great demand for snacks, particularly in the younger population. And it is possible to make these products more balanced in nutrition, richer in protein, through the process of extrusion. For example, I can state that we have combined cereals with soy protein to get high protein snacks, which still are well expanded, and it gives the taste and the sensation, but an extra effort has to be made to improve this protein content in those. So there is potential for snacks of good nutritional quality.
Wonderful, thank you. I know that snacks are not going away, and we will continue to have snacks as long as we have people. Well, thank you very much. This concludes our questions for today, and thank you to our panelists for your very interesting presentations and your participation in the panel. I would like to conclude by saying that you see, participants, the breadth of the presentations and the vast experience of the presenters, but we're still only have been able to sample some of the highlights of this very strong, flexible, multifaceted technology. It is our hope that the symposium participants and listeners will contact today's presenters with further questions, and that many rewarding collaborations can spring out of today's symposium session. We will be also having another week of the soybean seminar, so I welcome you to join us every day next week. Thank you very much.